What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 2, Section 7, Linear Inequalities and Absolute Value Inequalities. Let's do it. When solving an inequality, explain what happened from step 1 to step 2. So it looks like what they did here is they divided both sides by -2, right? So if we go here, you divide both sides by -2. But when you divide both sides or multiply both sides of an inequality by a negative number, you have to flip that inequality symbol. So the inequality symbol flips, and that's why we get x is less than -3. When writing our solution in interval notation, how do we represent all the real numbers? So we would set a lower bound of -infinity and an upper bound of positive infinity, and this encapsulates every real number. And remember, we never want the brackets with infinity because we're never including infinity. It's almost more of an abstract idea. So parentheses, -infinity to positive infinity, done. Describe how to graph y equals the absolute value of x minus 3. So the way I always start with these is first, what's going to zero this out? That's going to be the inflection point or the vertex. So I'm going to say, well, it's going to zero out at 3. So 3, 0, that's going to be my vertex. So we plotted at, let's say, 1, 2, 3, and boom. And then I know it's roughly going to go up in a V like this, but just to get specific values, now you can plot a couple points, but you realize to the right of this, it's going to be the function x minus 3. Well, let's plot some points. So if I plug in 4, for example, for x, it would be 4 minus 3, which is 1. So we'd have 4, 1. If I plug in 5, we'd get 5, 2, and so on and so forth. So you can see it's going to be this nice line going up to the right. Now, again, it's going to be a V shape. It's going to be the same line going to the left. But again, just to give some concrete values, let's plug in 2. So you do 2 minus 3, that's -1. And absolute value of -1 is +1. So now we're at 2, and you see it's going back up. Plug in 1. 1 minus 3 is -2, but absolute value of that is 2. So again, now we've got this point up here. Let me kind of get it even there. So there's 2. This is just approximation. And then you can see that going off to the left, we've got it sort of going the same way, a line with the slope of -1 instead of +1. That's how you do it. Done. So here we're going to solve this inequality and then write the answer in interval notation. I'm going to start by getting the x's together by subtracting 3x from both sides. We get 2 is greater than or equal to 7x minus 3x is 4x minus 1. Let's add 1 to both sides. Boom. And then 4x is less than or equal to 3. Last step, we're going to divide by 4. And when I write the final answer, I actually like to write x on the left and just keep that inequality consistent. So it's x is less than or equal to 3/4. So to put this in interval notation, again, we want to include every value that's less than or equal to 3/4, which means we're going all the way back to -infinity, and we're going up to 3/4. Now the question is, do we have parentheses or a bracket? Well, it says it's x is less than or equal to 3/4, meaning we want to include the 3/4, hence we do a bracket. Boom, done. First, we're going to start by distributing that 4, so we get 4x plus 12 is greater than or equal to 2x minus 1. Then I'm going to bring the x's together by subtracting 2x from both sides. So now I get 2x plus 12 is greater than or equal to -1. Then I'm going to subtract 12 from both sides, boom, and I get 2x is greater than or equal to -13. Then we're going to divide by 2, and I get x is greater than or equal to -13/2. So now in interval notation, we're saying greater than or equal to, so we're starting at -13/2. Again, I'm choosing a bracket because it's greater than or equal to, we're including that value. Now, since it's all values greater than this, I can go all the way up to infinity. Again, we always have a parentheses with infinity. Boom, done. We're going to start by distributing that 5, and we got, or -5, we got -5x plus 5 plus 3 is greater than, and I'm going to go ahead and combine this right now too. 3x and -4x makes -x minus 4. We're going to combine these guys as well. -5x plus 8 is greater than -x minus 4. Now we'll consolidate the x's. I'm going to add 5x to both sides, and that's going to give me 8 is greater than 4x, right? 5x minus x is 4x minus 4. Then I'm going to add 4 to both sides, and we got 4x is less than 12. Last but not least, we'll divide both sides by 4. And when I write it, again, I'll put the x on the left side, just my personal preference. X is less than 3. Now we want this in interval notation. It's everything less than 3. So we're starting at negative infinity going up to 3, but not including 3. It's not x is less than or equal to, it's just x is less than. So we end with another parentheses, boom, done. Here I'm going to start by getting rid of the fractions. You notice we've got something over 8, something over 5, something over 10. So I want to multiply everything by the least common multiple of 8, 5, and 10, just so I don't have to deal with the fractions. So what I'm going to multiply by is 40, because they're all divisible by 8. If 40 is divisible by 8, 5, and 10. So if I multiply this one by 40, right, up top, the 40 and the 8 are going to cancel out to a 5. So it's going to become 5 times x plus 3. If I multiply this one times 40, and don't forget that minus, the 40 and the 5 are going to cancel out to an 8. So it's going to be minus 8 times x plus 5. And then this is going to be greater than or equal to, if I multiply this times 40, the 40 and the 10 are going to cancel out to a 4. 4 times 3 is 12. So now this looks a lot better. Now I'm going to distribute these guys like so. So I'm going to get 5x plus 15 minus 8x minus 8 times 5 is minus 40 is greater than or equal to 12, add or combine like terms. 5x minus 8x is negative 3x. 15 minus 40 is negative 25 is greater than or equal to 12. So now we're going to add 25 to both sides. Boom, boom. And we get negative 3x is greater than or equal to 37. Last but not least, we're going to divide by negative 3 like so. When you divide by a negative, you have to flip that inequality. So x is less than or equal to negative 37 over 3. Now we put in interval notation. It's less than, so it's all the values beneath this. So we're starting at the bottom at negative infinity up to and including, because of the less than or equal to, including negative 37 thirds. So we have a bracket, boom, done. So what we do when we solve these absolute value inequalities is we generally split it into two inequalities. So we'd say x plus 9 is greater than or equal to negative 6, and x plus 9 is then less than or equal to positive 6. We'd flip that. But this is a very interesting case. So you want to always do this analysis right before you get started with the normal protocol. And what you want to look at is this side negative? And if it is, you have one of two possibilities. If it's an absolute value being less than a negative, no solution. Because absolute value is always going to be positive. It can never be less than a negative. Conversely, if it's greater than a negative, well, it's always going to be greater than negative because the lowest this can go is 0 if we have negative 9. So this is going to be a situation where any value of x is going to satisfy this inequality, which means the solution is all real numbers. And the way we'd write this in interval notation is everything to everything, negative infinity to infinity, done. So this one we're going to start by splitting it into two equations or inequalities. I got 3x minus 1 is greater than 11. So we're just really not changing anything, just removing the absolute value. And then I got 3x minus 1. We flip the inequality and we negate the other side is less than negative 11. Here I'm going to add 1 to both sides, and we got 3x is greater than 12. Divide by 3, and x is greater than 4. Over here, we're going to add 1 to both sides. Boom, boom. 3x is less than negative 10. Divide by 3, and I get x is less than negative 10 thirds. We got two inequalities. Now the question is this an and situation or an or situation? So the way to tell that is we look back to the original inequality, and if it starts as the absolute value is greater than 11, this is an or situation, meaning x can either be greater than 4 or less than negative 10 thirds, and in either case, it's going to satisfy this equation, this inequality. So if you plug in 5, for example, to be 15 minus 1 is 14. 14 is greater than 11. It works. Plug in something less than negative 10 thirds. That's like about negative 3, but a little more. So if you plug in negative 4, it'd be negative 12 minus 11, negative 13. Absolute value of that is 13, which is greater than 11. So both of these work. Now, if we want interval notation, we start with everything less than negative 10 thirds. So that starts at negative infinity going up to negative 10 thirds, but we don't include it because it says just less than, not less than or equal to. And then an or is like a union. So we join it. We say this plus this interval, which is everything from 4 all the way up to positive infinity. So that's your interval notation done. Here we want to start by isolating that absolute value. So we have absolute value of x minus 2 is now greater than or equal to 10 minus 4, which is 6. Now we're going to split this into our two sides. So we have x minus 2 is greater than or equal to 6. X minus 2 is less than or equal to, flip that, and then negate that, negative 6. And then we solve, add 2, boom, and we get x is greater than or equal to 8. Here we're going to add 2, boom, boom. X is less than or equal to negative 4. Again, we started with greater once we were isolated. So that means this is going to be an OR situation involving a union. So now we're going to have x is everything less than negative 4. So we're negative infinity up to and including negative 4 because of that less than or equal to. So we got a bracket. And this is unioned with starting at 8 and everything greater than 8 all the way up to infinity. Boom. Done. All right, so once again, we could start with our typical routine, but remember I said we always want to look and say, hey, wait a minute, do we have a negative on this side? We do. And this is saying an absolute value is supposed to be less than a negative. That's not possible. Where the lowest this is going to go is when we have 7 for x, that's going to be 0. It's still not less than negative 4, which means there is nothing that satisfies this, so this is a no solution situation. So we're going to start once again by splitting this immediately. First, we have x minus 3 over 4 is simply less than 2. That's great. Then we have x minus 3 over 4 is greater, right? Flip that inequality and then negate it, negative 2. Now we're going to solve. Multiply both sides by 4. X minus 3 is less than 8. Then we're going to add 3, x is less than 11. Then we're going to multiply both sides by 4, and we get x minus 3 is greater than negative 8. Then we're going to add 3 to both sides like so, and we get x is greater than negative 5. So here we started with a less than. So this is an and situation, meaning it's the intersection of these two intervals, meaning the only values that will work are values that are both greater than negative 5 and less than 11, like 10, 6, negative 3. Anything outside of that scope, outside of that realm is not going to work. It's not going to satisfy this inequality. So to represent this, it's everything greater than negative 5 and less than 11, not including 11. So there's your interval done. So here we're trying to include all the values that are within a distance of 3 units from the number 9. The way that we can represent this in an absolute value inequality is, hey, we've got a number x, and the distance or difference of 9 has to be within 3 units, less than or equal to 3. So 3 or less than from 9. Now we can just solve this inequality to get the answer. So x minus 9 is less than or equal to 3. X minus 9 is, we flip it, greater than or equal to negative 3. Now we add 9 to both sides. X is less than or equal to 12. Add 9 to both sides, or x is greater than or equal to 6. And by the way, we started with a less than situation, which means this is an and situation. So this includes all values from and including 6 up to and including 12. Boom, done. So this one, we're trying to find all values that has a distance or difference of 1 that is within 11 units. And there's my inequality with absolute value. Now we can solve. So we're going to split it. X minus 1 is less than or equal to 11. X minus 1 is greater than or equal to negative 11. So we're going to add 1 to both sides here. X is less than or equal to 12. We're going to add 1 here. X is greater than or equal to 1 plus negative 11 is negative 10. And this is, again, an and situation because we're starting with that less than. So it's everything including negative 10 all the way up to 12 with another bracket. Boom, done. So here we've got a compound inequality, and we can solve everything simultaneously. So check it out. I'm going to try and get the x by itself first by adding 5 to every piece here. Boom, boom, boom. So then I got 2x is greater than x, and then negative 7 and 5 would be x minus 2, and this one less than 3x plus 6. Now I'm going to subtract x from every component as well. Boom. And we get 2x minus x is greater than negative 2, and that's less than 3x minus x is 2x plus 6. So now I'm going to split this compound inequality up. And of course, in a compound inequality, it's all an and situation. All right. So we're seeing where x is greater than negative 2. So I'm just looking at this portion here. And then we're going to look at just this portion here as a separate inequality. That's going to be 2x plus 6 is greater than x. I'm going to subtract x from both sides. That's going to be x plus 6 is greater than 0. Subtract 6. X is greater than negative 6. All right. So what we have now is x is both greater than negative 6 and greater than negative 2, right? This is an and situation because it's a compound inequality. So when are both of these inequalities again going to be satisfied, meaning it's going to be greater than negative 6 and greater than negative 2 for all values greater than negative 2? Because if you're bigger than negative 2, you're inherently bigger than negative 6. But like negative 5, negative 4, those are not bigger than negative 2, but they are bigger than negative 6, but it's got to satisfy both conditions. So all the values from negative 2 and up will satisfy this compound inequality. Done. Here we know we have an OR situation, so we're going to probably have a union in our final answer. So we're going to solve and isolate each one of these separately. So first, this one I'm going to add 5 to both sides. 2x is less than negative 6. Divide both sides by 2. X is less than negative 3. This one, I'm going to subtract 1 from both sides. That's 5x is greater than or equal to 6 minus 1, which is 5. Divide both sides by 5. X is greater than or equal to 1. This is an OR situation. So it's all values less than negative 3 or greater than or equal to 1. So this one is everything from negative infinity up to, but not including negative 3, or unioned with starting at 1. See, it's a square bracket because it's greater than or equal to all the way up through infinity. There's your solution set. Boom, done. For the following exercises, graph the function. Observe the points of intersection and shade the x-axis representing the solution set to the inequality. Show your graph and write your final answer in interval notation. So this one, they're asking us to graph it on an XY axis and then kind of look at the answer on the graph. So it's not the most efficient way, but let's go ahead and give it a shot. So first we've got x minus 1 absolute value. So remember, we find that vertex when this zeroes out. So the vertex is going to be at 1, 0, which we can say is right here. And then just to get another point, we can say it's going to be at, if I plug in 2, it'd be 2, 1. If I plug in 3, it'd be 3, 2. So you can see it's got like this nice V shape like this going up. All right. As we go to the left, again, I can plug in 0 and I get negative 1, which then absolute value becomes 1. So we got 0, 1, and it's going to be negative 1, 2, so on and so forth. And we get this nice V pattern. Okay. Now we've got this other equation that is simply, we could say it's like y equals 2. So that would be a horizontal line like so. And what we're trying to figure out is we're trying to figure out when this absolute value, when this x minus 1 is going to be greater than this 2. So that's going to be this region out here, all of those values where it's greater than 2, and this region out here, again, where everything is greater than 2. So you can roughly see from the graph, that's when, after x is less than negative 1 or after x is greater than 3. So if we want an interval notation to represent this, it's everything from negative infinity up to, but not including negative 1, because it's not greater than or equal to. And then we're unioning that with everything from 3 and greater up to infinity. Boom, done. Once again, for this one, they want us to graph and then use that to get our solution. So to graph this side, the left side, that'd be like the absolute value of x plus 7. We start where there's zeros out, and that would be when x is negative 7. So that's our vertex is going to be here at negative 7, 0. And then it's basically going to be a slope of 1 going up to the right, up to the left. So there's a representation of the left side, the absolute value of x plus 7. It's going to approximately hit here at 7. So it's not drawn perfectly to scale, but did my best. Now what about this 4? That's just like y equals 4. So that's going to be a horizontal line coming across here like this. And this is now asking for the region when the absolute value is less than y equals 4. So it's this portion here, less than, boom, boom. So again, this is an approximate graph. It's not perfect, but you can pretty much see, like, let's say roughly, it looks like it's going from negative 3 up to negative 11, right? So it's a little off, but that's generally where it would go. And you can test that out because negative 11 plus 7 is negative 4. Absolute value, that is 4. So that's the lowest it can go to still give you something less than or equal to 4. Likewise, negative 3 plus 7 is 4. So that's the highest you can go. So it's this range. And again, it makes sense. This is going to be a and situation, and that's also verified by the fact that this is starting as a less than or equal to. So now in interval notation, it's everything, and by the way, because less than or equal to, it's including -11 up to -3, boom, done. So once again, we're going to try and graph this left side, so that's x minus 2, absolute value of that. So we're going to start by finding that vertex when it zeroes out. That's going to be at 2, 0. So we can say boom, boom, right here. Now, once again, this is going to form that V. If you want, you can plug in a couple points. You can plug in 3, you get 1. Plug in 4, you get 2. It's basically going to have a slope of 1 going to the right and a slope of -1 going to the left here. Now to represent the left side, that 0, that's y equals 0. That's literally going to be this x-axis here, all right? So we're trying to find all the places where this absolute value function, this v function, is less than or below essentially the x-axis. Well, I don't think it ever goes below it. It touches it, but it never goes below 0. So this is a no solution situation. Done. So for this question, we're going to graph this as like y equals x minus 2, y equals 2x plus 1, and see where this side is greater than this side. So y equals x minus 2, that is a y-intercept of -2. And it's got a slope of +1. So there you go. That's the left side. And then the right side, 2x plus 1. So we got a y-intercept of 1 and a slope of +2. And there we go. So we want to know when this line right here is greater than this line. Well, first I'm looking at the intersection point. That looks like it intersects at -3, -5. So that's the point where they cross over. And the x minus 2 is bigger all for this region down here. So this is where it's larger. So if we want to put this solution in interval notation, it's everything from -infinity, right? Because all the way back, it'll continue to be greater. -infinity up to that x value of -3, but not including it because greater, not greater than or equal to. So there's your answer, done. So for this one, we're going to graph the left side. That's a slope of 1/2 with y-intercept of 1. So we go up 1 over 2, boom. And then for the right side, we have a y-intercept of -5 and a slope, again, of 1/2. So as you can see, these two lines are parallel, which means they're never going to intersect. We're trying to figure out when this one is going to be greater than this one. Well, since they never intersect, and it seems to be above it right here where we're looking at it right now, it's always going to be above it, which means this is going to work for all values of x, meaning the solutions are all real numbers, which you can represent in interval notation as everything from -infinity to infinity, boom, done. For the following exercises, write the set in interval notation. So check this out. This is just a different notation. They're saying that the legitimate values of x, the solution set, is everything from -1 to 3. So it's a compound inequality. It's an and situation, which means we can quickly translate that. It's everything from -1, not including, because it's greater than, not greater than or equal to, up to 3, another parentheses, boom, done. In this case, it's everything less than 4. So meaning we're starting at the bottom at -infinity, going all the way up to 4, but not including 4 because this is less than. So we put a parentheses, boom, done. So this one we want to convert to set builder notation. So we start with these squigglies and we say x is the variable. And this is everything from -infinity up to 6, meaning this is all values of x for that where x is less than 6. That's how you convert it, done. So for this one, this is all values between and including -3 up to 5. So again, we start with this x and a bar, and it's everything from -3, where x is greater than or equal to, because we're including that -3 because of the bracket, and then less than 5, little squiggly, done. So here we're converting this solution set to interval notation. So this is everything from -2, but not including -2 because of the open circle, up to -1, but we're including -1 because it's filled in, done. Here it looks like we've got everything all the way down to -infinity because that arrow just keeps going. So we're starting at -infinity all the way up to and including 4 because of the filled in dot, boom, done. So this problem is meant to be solved using a graphing calculator. I'm going to show you how to do it on Desmos. So we're going to do this as one function, this is the other, and see when the left side is less than the right side. So I'm trying to figure out when this function here is less than y equals 4. Well, if you look at it, it looks like it's pretty much always less than that because it's just going down. That's the highest point. So we can quickly see from the graph that the answer is all real numbers. I'm going to write that in interval notation as negative infinity to infinity, boom, done. So this one, once again, we'll graph in Desmos. Left side is y1, right side is y2. So we want to know when the absolute value of x minus 4, this red, is going to be less than or below 3. And check it out. We can see these nice intersection points. So it's everywhere from 1 till 7. And since it's less than, we don't include 1 and 7. So it's 1 to 7, done. When we have these double-sided absolute value, you basically bifurcate the exact same way as if you had a single side. So we're going to start with 3x plus 1 equals 2x plus 3. And then the other one is going to be 3x plus 1 equals negative 2x minus 3. So I'm just negating everything on one of the sides. It's kind of arbitrary which one. So now we're going to solve. We're going to subtract 2x from both sides, and we get x plus 1 equals 3. Subtract 1, x equals 2. So that's one solution. The other one, I'm going to add 2x to both sides like so, and I get 5x plus 1 equals negative 3. Then I'm going to subtract 1 from both sides. I get 5x equals negative 4. X equals, divide both sides by 5, negative 4 fifths. So my two solutions are negative 4 fifths, positive 2, done. So for this one, we want to figure out all the values that satisfy this inequality. And the only reason why they say x can't equal negative 7 is because we don't want to be dividing by 0. So that would be undefined. The way I like to solve something like this is to look at where we have zeros. Even though negative 7 is not an included value, we want to recognize that it goes away, like it goes to an undefined place. So our two critical points are negative 7 and 5. And then we can look at the signs on top or bottom within these set up ranges to figure out when this thing is going to be less than or equal to 0. By the way, negative 7 is not included in our solution set because it becomes undefined, but 5 is, because if we plug in 5, we actually get 0 divided by 12, which is 0, and that is less than or equal to 0. So now let's look, if we plug in values less than negative 7, like negative 8, for example, we'd get a negative on top, negative 13, and we get a negative on the bottom. That's a positive. And guess what? That's not part of our solution set because we want to know when this is going to be less than or equal to 0. If we look in here, we can choose any value. We can choose negative 6. We can choose 0. So I'm going to choose 0. So if I plug in 0, 0 minus 5 is negative. 0 plus 7 is positive. A negative divided by a positive is a negative. So this is part of our solution set. Last but not least, we're going to look at values greater than 5. So I'll just say 6. 6 minus 5 is positive. 6 plus 7 is positive. Positive over positive is positive. That's, again, not part of our solution set. So where we're in good shape is everywhere from negative 7, but again, not including it because that gives me an undefined value, all the way up to and including 5. Boom, done. In chemistry, the volume for a certain gas is given by V equals 20T, where V is measured in cc's, cubic centimeters, and T is measured in Celsius. If the temperature varies between 80 and 120, so temperature varies between 80 and 120, find the set of volume values. Well, at the lowest, when temperature is 80, you can just plug it in. This will give you the low value. So 20 times 80 is 1600. On the high side, now we can plug in 120. So 20 times 120 is 2400. So that means the volume varies anywhere from 2400 down to 1600. So if we want to put this in interval notation, it'd be 1600, including, because of the greater than or equal to, up to and including 2400. Boom, done. I hope you enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining. I'll see you in the next video. Take it easy.